In a groundbreaking achievement, France has set a new world record by successfully maintaining a fusion reactor's operation for an impressive duration of 22 minutes and 17 seconds, or 1,337 seconds to be precise. This remarkable feat is significant because sustaining long and stable plasma operation is essential for the development of future nuclear fusion power plants. This achievement surpasses the previous record established just weeks earlier by China's East reactor, improving the duration by approximately 25%. It demonstrates the capability of researchers to maintain challenging operational conditions without compromising the integrity of the reactor's internal surfaces. Anne-Isabelle Etienne, the Director of Fundamental Research at the Commissariat à l'Énergie Atomique et aux Énergies Alternatives, CEA, proudly announced this milestone. Understanding plasma and nuclear fusion within the confines of the West Tokamak, physicists utilized powerful magnetic fields to contain a rapidly moving gas composed of charged particles known as plasma. The challenge lies in managing the heat and exhaust produced during this process to ensure that the reactor components facing the plasma do not fail. West has achieved a new key technological milestone by maintaining hydrogen plasma for more than 20 minutes through the injection of 2 megawatts of heating power, stated Etienne. This was accomplished by injecting several megawatts of heating energy to sustain the fusion reaction. However, controlling the plasma is no small feat. Plasma is inherently unstable and can react negatively to any errors, with minor instabilities potentially escalating rapidly if not addressed promptly. The role of a tokamak. A tokamak functions as a ring-shaped magnetic containment vessel. Its magnetic fields guide charged particles, allowing them to circulate around the toroidal structure instead of colliding with the walls. This method, known as magnetic confinement, enables scientists to heat a thin gas until the atomic nuclei possess sufficient energy to fuse, thereby releasing more energy in the process. Looking ahead, the next significant step for France is the construction of the larger ITER device, which is currently being assembled in the same region. ITER is designed to generate approximately 500 megawatts of fusion power, using around 50 megawatts of heating power in the plasma. Comparing fusion records, while long operational durations are crucial, they represent just one aspect of the fusion energy puzzle. Energy output is another vital metric. For instance, the JET facility in the United Kingdom achieved a record by producing 69 megajoules of fusion energy in a brief 5-second pulse using a minimal amount of fuel. This result highlights a high energy release over a short duration, contrasting with the West reactor's focus on maintaining stability over an extended period without prioritizing high fusion power output. Different fusion devices are designed to explore various limits, and this diversity is intentional. Together, they provide a comprehensive understanding of what future fusion power plants must achieve consistently. The importance of long pulses for a fusion power plant to operate effectively. It must run for extended periods while maintaining its health. This requires stable temperatures, clean fuel, and components that do not degrade or contaminate the plasma. Additionally, effective exhaust management is essential. The plasma must be able to release heat and particles in a controlled manner to ensure that the metal surfaces behind the magnetic field remain within safe operational limits. Materials play a crucial role in this process. For example, tungsten, which is used in the divertor region of the West reactor, can withstand high temperatures but still necessitates careful handling to prevent damage or the introduction of unwanted impurities. It's important to note that a 22-minute plasma operation does not equate to net electricity generation. The West reactor is primarily a research facility, and this particular test was focused on stability and control rather than on producing more energy than it consumed. Achieving net energy involves a complex interplay of factors, including plasma density, temperature, and the efficiency of heat and particle confinement. It is a multifaceted challenge rather than a simple adjustment of a single variable. Chapter 4. The future of plasma and fusion. The team at CEA is planning longer experimental campaigns while gradually increasing power levels. Each extension of these experiments contributes to a more robust understanding of safe and repeatable operational practices. The data gathered from the West reactor will be invaluable in guiding engineers as they prepare to operate ITER when it becomes operational. This transition from experimental setups to larger-scale applications is crucial for advancing fusion technology from laboratory experiments to practical energy solutions. Fusion reactions do not produce long-lived radioactive waste like traditional fission reactions. However, the fast neutrons generated can activate the metal structures surrounding the plasma, which underscores the importance of material selection and reactor design. International guidelines indicate that while fusion minimizes the production of long-lived waste, it still results in activated components that require careful handling and temporary storage. Additionally, tritium, a radioactive isotope with a short half-life, is utilized in a closed-loop system on-site. This context highlights why researchers prioritize the durability of reactor components and the meticulous management of fuel and exhaust. Despite the challenges that lie ahead, the advancements made at the West reactor signify a significant step toward realizing practical fusion energy. Each new record serves as evidence that these machines can maintain plasmas for longer durations, at higher temperatures, and with greater cleanliness, laying the groundwork for reactors that could one day deliver substantial amounts of safe and reliable power. Did you find this information enlightening? If so, consider subscribing to our newsletter for more engaging articles, exclusive insights, and the latest updates in the world of fusion energy. Also, check out EarthSnap, a free app developed by Eric Rawls and Earth.com for more fascinating content.